Hey guys, we're going to spend a few minutes talking about quadratic equations. Okay, there of course are two forms of quadratic equations. There are standard form and vertex form. Okay, our standard form is given to us by ax squared plus bx plus c. Okay, now these are very helpful for when we are looking for roots, when we're trying to find solutions to our equation. Okay, these are our x-intercepts or our zeros. Okay, those all mean the same thing, and to find those we have to have it in standard form. Now the other form is vertex form. This one's also very handy because it gives us our vertex and also gives us a lot of other information. So let's look at let's look at an example. We're going to have y equals x plus 5 squared minus 1. Okay, now one thing we really need to be able to do to work with quadratic equations, and especially graph them, is we need to be able to convert between the forms. So let's try converting vertex form into standard, and it's very simple. All we have to do is multiply this out. Okay, this is x plus 5 times x plus 5. So we'll FOIL it. We end up with x squared plus 10x plus 25. Now let's not forget about our -1 here. We need to bring him down too. So, can we leave it like this? No, of course not, because we need to combine like terms first. So we're going to get x squared plus 10x plus 24. Okay, so this is now the standard form of our original function. Now, to convert back to vertex form, it's a little more complicated, but it's not that bad. If you know that vertex form is going to look something like this, you can go ahead and put that down and try to fill in the blanks. Our h value, which we see from our generic formula, is given to us when we take half of b from our standard form. So if we divide 10 by 2, we should get our h value. Okay? Look good so far? And this is positive because in our standard form we have x squared plus 10x. Now we're going to take our h value here, we're going to square it and get 25. Okay, we're going to go back to our standard form here. We're going to subtract 25 from our c value. This will give us -1. This becomes how we fill in k. And there we go. This is what we end up with, and it's what we started with. Okay, so we know we converted correctly. So, where do we go from here? Well, since we know that vertex form is this, x plus 5 squared minus 1, we're going to get our vertex from this. We're going to go ahead and collect that information. So our vertex is going to be h. Now in this case, look, we have x plus 5, but our generic formula is x minus h. So we have to account for that sign change. So h is not actually just 5, it is -5. Because if you plug this in to our generic formula, x minus a -5 will give us x plus 5. K is going to work the same way. You notice we have -1. In our original formula we have plus k. So for this to work, our k value is negative. So if you look at your standard form of a quadratic equation, you have x plus 5 squared minus 1, you're going to have to take the opposite sign that's in here for x, but you're going to take the sign with it for k. So our vertex is -5, -1. Now, let's look over at our standard form. Standard form we identified as x squared plus 10x plus 24. Now, if we want to find our roots, we can do that two ways. Okay? We can either factor or we can use the quadratic formula. Now, this equation is one we can factor, so it's going to be easy. Alright, we end up with x plus 6 times x plus 4. Okay, this is going to make things a whole lot easier on us, because what we want to do with our zeros, our solutions, our x-intercepts, which mean all the same thing, is that we have to find values of x where y becomes 0. So, this equals 0. We need to find values for x that will do that for us. And in this case, it becomes easy. What in this binomial would make our function 0? It would be negative 6. Here, if we take this binomial and make it 0, we get negative 4. So our zeros, or our solutions, are going to be where x is negative 6 and negative 4. Okay? Now we've got 3 key points. So if we want to try graphing one real quick, we can do that. Alright, let me make a little bank over here. Vertex is negative 5, negative 1, and we have zeros at negative 6, 0, and negative 4, 0. Okay? Remember, this is where y is 0. Now let's try drawing a graph. Alright. Let's draw a set of axes here. And our vertex is at negative 5, negative 1. So let's go over 5 into the negative here and negative 1. And that's going to be our vertex. We need one more to account for one of our zeros. So we need this point and we need this point. Now these 3 points already tell us and already show us what direction our parabola is going. Okay, it's going to open upward. Now if we didn't know that, we didn't already graph these points, we could already tell that because of our a values. Okay, if a is greater than 1, or if a is greater than 0, alright, it's going to point upwards. If it is less than 0, it will point downwards. Okay, so if it has a negative, it goes down. If it's positive, it goes up. Okay? So we'll try drawing a little bit of our graph here. And it's not very good because I'm not a very good artist, but hey, you get the idea. Okay, our vertex, our zeros, and we draw it, and we sketch our graph. Going back to our axis of symmetry, this is where x is negative 5. We'll just draw a little dotted line here. A vertical dotted line, and that tells us what our axis of symmetry is. So if we folded this function over onto itself, it would match. Okay, it would be symmetrical. So hopefully this helped refresh some of your memories. Help get you a firmer grasp of what we're doing, because you have to be able to convert between vertex and standard form and be able to graph these functions. Okay, so if that helps. Have any questions, let me know.